in order for us to understand why integration works, we need to understand the fundamental theorem of calculus 1 and 2. But in order for us to understand these two, we need to understand all of these. And we've already seen the mean value theorem. We've already seen this. In this video, we're going to look at this thing here. But ultimately, we really want to use this. It is this that allows us to understand these two. But in order to understand this, we need to use this thing here. So this thing here will allow us to understand this. But in this video, we're going to look at this first, and then we will look at this. But really, it is this thing here that allows us to understand the fundamental theorem of calculus 1 and 2. So let's look at this now. So this is the textbook's explanation. Now I'm going to give you my version of the explanation. So hang on. So if f prime is always equal to 0 in between a and b, then f of x must be a constant. So what that means is, hang on, you know, if I were to give you f of x equals, let's say, a constant, the number 4, so y equals 4 looks like this at a height of 4. So if you're standing here and you're walking along, you're flat, so the gradient will be 0. If you're standing here, the gradient is flat. You're not going uphill, you're not going downhill, it's flat, so the gradient is 0. No matter where you stand on here, the gradient is always 0. If you're standing here, the gradient will be 0. So this is saying that if the gradient is always 0, meaning it's always 0 along here. That's why f prime of x is always equal to 0 for each point, meaning always equals to 0 on the interval a and b. So hang on, let's just say this is a here and this is b here. So if it's always equal to 0 in between a and b, so it's a horizontal line here, it's always 0, then the original function itself, which is f of x, must be a constant. In our case, it's 4, but it could also be y equals 5. For y equals 5, because it's horizontal, the gradient will always be 0. It will always be 0. So what this is saying is that if the gradient is always 0, then the original function itself must be a constant. So if the gradient is always 0, then the original function itself must be a constant. So that's what it's saying. Okay. So in the next video, we're going to use this to try and understand this thing here. It is this thing here that's important. This will allow us to understand these two. Okay.